In this video, I'm going to show you how to compute a simple numerical expression using the order of operations. So let me remind you what the order of operations look like. First, we perform exponentiation. Then if there is no exponentiation, we perform multiplication and division in the order they appear from the left to the right. Then if there is no multiplication, division, nor exponentiation, we do addition, subtraction, again in the order that they appear from the left to the right. Now, this default order can be changed if we introduce grouping symbols. So the rule is anything inside of the grouping symbols, such as parentheses, brackets, has to be done first. And now another remark is that if we have a radical or absolute value, then what's inside of radical or inside of the absolute value is treated as if they had parentheses around it. Also, if you have a fraction like a long division bar, the numerator and denominator of this expression then treated as if they had parentheses around them. So we compute the numerator and the denominator of a fraction first before we actually consider doing the division itself. So in our expression, numerical expression, what we have a one long division bar, then absolute value on top, and log and square root on the bottom. So we can focus on multiple expressions at once. So let's look at the absolute value and see what we can do inside of the absolute value. Inside of the absolute value, what we see is another set of grouping symbols, and inside there we have -3 minus 7. So this -3 subtract 7 has to be done first. So we do that first and we produce -10. Now we have multiplication here, so we have to multiply 2 by -10. 2 times -10 is -20. Now there is no multiplication, no exponentiation, so we do the addition of these two numbers. So what's inside of the absolute value is 25. And absolute value, only now after we've done everything inside of the absolute value, now we can find the absolute value. So absolute value of 25 is 25. Next we can focus on the radical. And what do we see inside of the radical? We have exponents. So exponents have to be done before anything else. So 10 squared is 100, 4 cubed is 64. Again, we treat what's inside of the radical as if there are parentheses around it. So we have to do this first. So 100 minus 64 is 36. So square root of 36 is 6. One last piece that we can figure out is log of 81 base 3. How do we find log of 81 base 3? Well, the question here is 3 to what power is equal to 81? And the answer is 4. So it is 3 to the 4 that is equal to 81. Therefore, log of 81 base 3 is 4. So after we worked out the expressions inside of the absolute value, inside of the radical and the log, now we can put it back together into this division. So in the numerator we have now 25, in the denominator we have 6 plus 4. And now it's a very simple expression. We just perform the operation in the denominator first, and as a result we got a fraction, 25 over 10, which can be reduced by 5. So the final answer is 5 halves.